Good morning, everyone. As you know from the announcement earlier today, we're covering hypothesis testing for the least squares regression model. I wanted to go through one of the homework problems just to make sure it's really clear how you how you would do this, excuse me, in StatCrunch and how you would get the results from the output. So we're going to look at number 3 in the MyStatLab assignment. The first problem, so for the data set shown below, complete parts A through D below. First, we have find the estimates of beta naught and beta 1. Remember, these are the estimates of the slope and intercept of our least squares regression model. Remember, B naught is our intercept, B1 is our slope. So let's open our data set in StatCrunch. Go to Stat, Regression, Simple Linear. Select your X variable and your Y variable. And we're not going to worry about any of the other stuff right now. Just click Compute. And let's get a look at our results here. So here you can see it tells us our X and Y variables, the dependent and basically your predictor and your response variable, like Y is dependent on X. Here's your equation, Y equals negative 2.3 plus 2.09 times X. That's our equation. Here it gives us our sample size, the correlation coefficient, R squared, estimate of standard error and estimate of error standard deviation. We're going to look at that in a little bit. But right now we need the estimate for our slope and intercept for part A. And these are the same numbers you see up here on our equation. So in this case, our intercept is B naught. So our B naught is equal to negative 2.302. And our B1 is equal to 2.093 since it asked us to round to 3 decimal places. So we have negative 2.302 and 2.093. Check answer. Okay. So the next one says compute the standard error, the point estimate for sigma. This is computing our standard error between our estimate and the actual, the Y and the Y hat. In this case, that is this right here, estimate of standard error right here. So we need to round to 4 decimal places. So that's going to be 0.4659. Let's check our answer. Okay, now assuming the residuals are normally distributed, determine SB1. Remember, B1 is our slope, and this S is for standard error. So we're looking for the standard error of our slope. That's right here. So we're rounding to 3 decimal places, so that gives us 0.112. Okay. Now, assuming the residuals are normally distributed, test the null hypothesis that beta 1 is equal to 0 versus the alternative hypothesis that beta 1 is not equal to 0 at the alpha equals 0.05 level of significance. Use the p-value of this. Now, I want to point something out. This is basically saying that we're going to test the null hypothesis that there is no linear relation, which is where that's equal to 0, or there is a linear relation, whether it's negative or positive. Just any linear relation is when beta 1 is not equal to 0. The slope is not equal to 0. So let's look back at our results again. I just want to point out, in our original, when we originally started this thing, it automatically selects hypothesis test. In this case, our null hypothesis is equal to 0. Our alternative hypothesis is not equal to. Now, if we want to do less than or greater than, we would select it here. But in this case, we already had it selected, but we'll click compute again just to show you. So in this case, it tells you the same exact numbers. Our alternative hypothesis is not equal to 0. And the other thing is it automatically runs a test on both the slope and intercept. For our case right now in this problem, we are only looking at the slope. So our p-value is 0.0003. Since we're rounding to 3 decimal places, that's just 0. Now, recall back from any hypothesis testing, and it is specific in this, or it is also true in this case, if our p-value is less than alpha, then we reject the null hypothesis. Well, alpha is greater than 0. So in this case, our p-value is 0, which is less than 0.05, which is our alpha. So we would reject the null hypothesis. So we already know it's going to be B or D. Let's read the rest of it. It says there is sufficient evidence at the alpha equals 0.05 level of significance to conclude that a linear relation exists between x and y. Part D says the same thing, but it says to conclude that a linear relationship, there is not sufficient evidence at this level to conclude that there's a linear relationship. Now remember, we talked about our alternative hypothesis where beta 1 is not equal to 0 means that there is a linear relationship. And when we reject the null hypothesis, we say that there is sufficient evidence to support the alternative. So in that case, that means B. And well done, that answers everything. So if you guys have any questions about how to run a hypothesis or any least square regression model questions, please let me know. And again, use that general questions topic on the discussion boards or email me directly. Thank you.